So the next chapter is about machine learning, and we'll be learning the basics of machine learning as part of the introduction part, that is machine learning paradigms. So when I talk about machine learning is an area which can be used for in different areas. Like you can apply machine learning for image processing, you can apply machine learning for any real-time problem, whatever you are having. So machine learning has wide applications. So whenever you are learning about machine learning, you come across three important uh, classification of machine learning algorithms, that is supervised, unsupervised, and reinforcement learning, which are called as the paradigms of your machine learning. Okay, be very clear about this point, guys. So this question will be most commonly asked about if you are proclaiming that I am good at machine learning, people will try to ask you about what do you know about machine learning and what are the machine learning paradigms. So you need to answer it right. Supervised, unsupervised, and reinforcement learning are the three classifications of your machine learning algorithms. Okay, so this is the introductory part of your unit 4. So we'll try to address these three concepts in today's session. So before going on for the classification of this, let's try to understand how machine learning can be useful and what actually is this machine learning. So this is a very common word for a computer science student about learning this machine learning. So the applications of machine learning can be like it can be applied to almost any problems, and it has been used in predicting cancer, predicting traffic patterns, match people up for dating, recognize faces like facial expressions, which is a very common trend now, taking this various emojis, expressions, captioning images, and much more. Like you can do any sort of task using your machine learning approach. So depending on the unique problem at hand, different machine learning techniques are used to deliver an effective solution. As I said, it can be supervised learning, or it can be unsupervised learning, or it can be reinforcement learning. Depending on the type of problem what you are having, you will be trying to deliver an effective solution for the problem. That can be done using your machine learning. Okay, yeah. So we actually discussed about these three concepts of machine learning as part of the basics of machine learning, that is about what is supervised learning, what is unsupervised, and what is this reinforcement learning. Okay, so here's a brief picture of what we are learning in today's session. So we are trying to very clearly understand the concepts of machine learning. Yeah. So here you can see a small learning model include supervised learning, unsupervised learning, and reinforcement learning. So from the picture you can see about the supervised learning, it's like you'll be having some labeled data. That means data will be having a proper structure. Data will be labeled. Suppose if I take student data, you will be having data with respect to what is serial number, what is the name of the student, what is the hall ticket number. Likewise, you will be having the attribute names. Data will be labeled, and the values also will be according to the labels whatever you are having. And you'll be having a direct feedback of your what is the input and what is output will be very clearly defined. And if I talk about unsupervised data, it is that data will not have labels. That means a machine need to understand what is this data, and because it is not having labels, it is a task for a machine to understand how data is being classified, and there will not be a proper feedback, and it should understand the hidden structure from the given data. And next, coming to your reinforcement learning, this is where we actually apply the knowledge of your artificial intelligence. So this is a decision making process. So here the data will not be properly available. A machine need to understand from the inputs given by the user, and according to the knowledge what data it is having, it need to make some decision. This is where an intelligent machine or an expert system comes into picture. Okay, so basically supervised and unsupervised learnings are classified in terms of machine learning, and when we talk about this reinforcement learning, it will be a part of your artificial intelligence concept. Okay, yeah. So now let's get into the concepts of this supervised learning. So as I said, supervised learning will have data classified. That means data labels will be very clearly defined. So a supervised learning is a machine learning task in which the function maps the input to the output data using the provided input output pairs. So you'll be having some input, you'll be having some priorly given output, and you will be mapping just input to output. That is a very easy task when compared to other tasks of your machine learning. So you'll be having your input and you will be knowing your output. You need to just map your algorithm such that what is the input and what is the output. So supervised learning is considered as the easiest approach among all the three learnings of your machine learning. So you need to give both the input and output to your algorithm, and the computer will understand what are the inputs and what are the outputs, and accordingly it will try to give you data. So just give me 1 minute. Okay. A computer does what it does is that it generates a function based on the given input data, which can be anything like a simple line to a complex convex function, depending on the data provided by the user. So according to the data, whatever you are providing to the machine, it will try to understand from the given data, and accordingly it will try to ask you what should be the output, and the output will be displayed. So supervised learning is classified as the easiest learning among the all the three approaches. So here's a small picture like what actually happens in your supervised learning. So everybody need to be very cautious here. You need to understand the concept with this architecture. So you'll be having some input raw data given to you, and that raw data need to be classified, and you need to get some proper output. And here you can see there's a mixture of your data, like you can see the red color, purple, and green color. All are grouped at single place, that is called as raw data. So whenever you are having your raw data in your real world, it will be something like this, and you need to classify your data into such patterns. That is the output what it is expecting. So you need to classify red separately, green separately, and purple separately. That is the task given to a machine learning. So how it does is, so it will try to take this input data, and that input data will be given to your algorithm. So here you can see there is some supervisor who is saying, who is training this algorithm. He is giving some training data set, and he is saying what is the desired output. That will be fed into an algorithm, and algorithm will apply the techniques according to the inputs provided by the supervisor, and will process the data, and it will be giving the output. So it is very simple task here. Data, input data will be given as raw data. That raw data need to be classified into training and testing data set. That's what a supervisor does here. He will classify data into training and testing modules. So that depends on the supervisor, that what is the training data and what is the test data. And the desired output also is, that is the test data will be given to the algorithm. Then the algorithm will process it. It will be going on to the next step, that is processing phase, where you'll apply many methods, like it can be classification method, it can be a support vector machine model, or any model can be applied to the data. So according to the data whatever you are providing, the algorithm will be chosen, and accordingly you will be getting your outputs. So this is the model for your supervised learning. Okay. So so as I said, this is the most basic type of learning paradigm. So here are some of the example or some of the classification algorithms what are classified as the supervised learning. So you can see linear regression, the simple line function is one example of supervised learning, and also logistic regression, where you'll be having some binary data. So whenever you are having your binary data like yes or no or 0 or 1, then that type of data will be classified as supervised learning. So according to the input given by the user, you need to say whether the new data arrival is true or false. That's how we actually do the regression concepts. So logistic regression and linear regression are the concepts which are linked to your supervised learning. Okay. Yeah. So next, classification and regression, as I said, are also part of your uh, supervised learning, but not all the classification algorithms comes under this approach. Only some classification mechanisms, we will be seeing what are those mechanisms. They will be classified into this supervised learning. So machine is trained to classify something into some class. As I said here, you'll be having your data points like this, and you will be trained to classify your data into these modules. That's the task given to a machine learning concept. For example, here you can see classifying whether a patient has a disease or not. Suppose if I give you 100 samples of 100 people's of data, you need to classify them based on the symptoms whatever they are having or the reports whatever are collected, and you need to classify whether the person is having a disease or not. So if suppose if I take example of a corona patient, suppose if you are having 100 samples data of users, you need to classify how many members are having some corona disease or not. So how you will do that? Algorithm will try to take a number of inputs, whether he is having cough or fever or headache, temperature of the body, all these things will be collected, and a model will be trained accordingly. And whenever a new user is giving some input according to the algorithm, it will try to classify. That is where supervised learning comes into picture. So classifying whether an email is spam or not. So according to the data given to the algorithm, it will try to segregate whether an email is spam or not. So these are some of the examples of classification with respect to your supervised learning. So next, so as I said previously, like linear regression and logistic regression, which are the concepts of regression. So here a machine is trained to predict some value like price, weight, or height. Suppose if you want to say, I want to buy a new house. So if you want to buy a new house, if you are, if you want to predict whether the price whatever I am keeping is suitable or not, you need to input a number of parameters, like you need to take what is the area, locality, number of rooms, the number of rooms whatever it is having, whether it's having a parking space or not. Likewise, you will try to feed a number of parameters into your algorithm, and accordingly you will use for prediction whether the price whatever I have kept. Suppose if I say 50 lakhs is the cost of my house, the machine learning algorithm will decide whether the price whatever you are keeping for that area is enough or not, whether it is more than what you are keeping. So that's how regression can be used for your prediction. Classification is used for classifying your data into different classes. Regression is used to predict the future based on the inputs given by the user. These all concepts come under supervised learning in machine learning. Okay, yeah. So broadly speaking about your supervised learning, so we utilize machine learning to determine an unknown function f by analyzing specific set of data samples. So in supervised learning, the example data set contains both input and output values. That is what we have said earlier. So you will be allowed to provide input and output. So here you can see x1 y1 x2 y2 so on, xn yn, where yn values indicates the output and x1 are the input values. Okay, so thus supervised learning is what most people understand machine learning to be, but machine learning can be applied to many other types of problems. It can be applied for intrusion detection, it can be applied for spam filtering of emails, it can be applied for image processing, where you need to classify many images. It can be used for face recognition applications. So likewise, depending on the type of data what you are providing, it can be used in a number of ways. Okay, yeah. So moving on, the next concept is about machine learning paradigms is unsupervised learning, which is quite opposite to what you have learned in supervised learning. So in this type of learning paradigm, the computer is provided with just the input to develop a learning pattern. So you will not be given what is the output, you will be just providing what is the input, and it's about learning from no results. So you will be just having the inputs, and according to the inputs given, a system need to understand what is the output and it need to process its data. So this means that a computer has to organize or recognize a pattern according to the input data provided, and it need to develop an algorithm accordingly. So it is concluded that machine learns through observations and finds structures in data. So it is a bit complicated than supervised learning, and many organizations or many MNC organizations like Google and Microsoft, they are currently researching on these topics of machine learning. Like it is trying to develop new algorithms, like what you can say, fingerprint applications, the eye lock applications, all these come under this unsupervised learning. Okay, So we will try to see what is the model for this algorithm. So compared to your supervised learning, you can see here, here again you are having input raw data, but as I said, you will not be having the class labels or the training data is not provided here. So here you can see unknown outputs and no training data set is provided. Machine or algorithm need to take this data and it need to understand the patterns of the data. According to that, an algorithm will be provided and it will be giving the results. So if somebody asks you what's the difference between supervised and unsupervised learning, supervised learning data will have class labels and training data will be provided and output also will be provided. But coming to your unsupervised learning, here the data whatever you are providing is same, but here there will not be any training data set, there will not be the output parameters will be given, and a machine need to understand it according to the patterns whatever it's having. That's why it is considered as a bit complex algorithms will be available as part of your unsupervised learning. Okay, in the working strategies, rest of the concepts are same. At the initial phases only, it will be varying. Okay, so clustering and association mining come under the examples of unsupervised learning. So if I say classification, previously is like classifying elements into different classes. So coming to clustering, clustering is collection of similar objects into a single place. A clustering problem is where you want to discover the inherent groupings into data, such as grouping customers by purchasing behavior. So if you want to understand the behavior of the customers, then you go for clustering. And also if I say association rule mining also talks about the behavior of customers. Suppose if I'm buying some product X, whether a person will tend to buy Y or not, that is recommendations come under this association concept. Okay, yeah. So next machine learning paradigm is about reinforcement learning, which is the third module of your machine learning. This is where we talk about AI, that is artificial intelligence. So reinforcement learning is a type of machine learning and thereby also a branch of artificial intelligence. The first two algorithms are basically confined to your machine learning, but when we talk about this reinforcement learning, we dive into artificial intelligence also. So it allows a machine and a software agent to automatically determine the ideal behavior within a specific context in order to maximize its performance. That's what we are talking about your intelligent machines, where it will try to take data from the users and according to the domain expert knowledge provided, that is what we call it as expert system, it will try to predict and it will try to make some decision. Okay, so let's try to discuss about what actually is this. So here is the concept of learning pattern in reinforcement learning. So you can see here you will be having an intelligent agent and according to the data environment provided by the domain expert, so you'll be having some observations and all those components and it will be linked to you again to your agent. So what action need to be taken depends on the domain expert knowledge provided to the expert system, and accordingly it will provide the observations for the given data. Okay, so we take a small example to understand what is the reinforcement learning here. So everybody will be basically training a dog. So if you are training a dog, how we actually do that? So we'll be trying to train a dog, like you will be training to say it hello, or initially you will be clapping and asking it to jump. So you will be showing some specific signs in your with your hands, and according to that a dog will understand that a trainer is trying to train me something, and it will try to train among itself. So initially the same in the same manner a machine learning algorithm also try to understand from the domain expert knowledge whatever it is giving, and according to that input given by the user it will try to give some decision. So whenever the dog responds correctly, the trainer gives a reward to the dog, which can be anything whatever the training is given. In the same manner, if the algorithm whatever it is being developed, if it is success, we make that this is the best algorithm and we take it forward to the next phases. Okay, so coming to how how reinforcement learning can be applied in real world. So a variety of different problems can be solved using your reinforcement learning. So one second, guys. Yeah, talking about reinforcement learning, it has wide applications in real world. So all the recent trends or the recent applications, whatever you are going to link to your artificial intelligence, mainly comes under reinforcement learning. So a variety of problems can be solved using your reinforcement learning. So because reinforcement learning agents can learn without expert supervisor, then the type of problems that are best suited for reinforcement learning are complex problems where there appears to be no obvious or easily programmable solution. So coming to previous concepts, whatever we have discussed about certainty factor theory or the expert system concepts, they are linked to your reinforcement learning. Okay, so here are some examples what we can show with respect to your reinforcement learning. So we have learned about game playing in the earlier concepts. So there we have seen some constraint satisfaction problem, the different concepts of your unit 2 which are linked to your reinforcement learning. So determining the best move to make a decision in a game uh, often depends on number of different factors. Suppose if I take example of a chess game, or we have seen many problems like missionaries and cannibals problem. So all these, like if you want to make a next move, you need to make some decision. This here we need to see number of possible states that can be exist in a particular game, in usually very large type of games. So there we try to apply reinforcement learning with respect to your game playing. And next one, control problems such as elevator scheduling. It is not obvious what strategies would provide the best movement or most timely elevator services. Like there are a number of problems which can be linked to your reinforcement learning. Okay, yeah.